I am standing on the top of an 8-foot high bridge and I'm reeling a fish in at a constant rate. And we could say that I'm reeling it in at 2 feet per second. So my question is, how fast is the fish moving through the water when the fish is 10 feet from the bridge? And what's kind of interesting about this is you can see that as I reel the fish in at a constant rate, it actually moves faster and faster and faster, right? I'll move 5 feet now and the fish moves quite a bit, but the next 5 feet, fish moves even more than that. Well, I'll do it one more time. This is so much fun. So as I move at a constant rate, I'm trying to move at a constant rate on top. The fish is moving faster and faster and faster. And my question is, how fast is the fish moving when it is exactly 10 feet from the bridge? I always like to start out by labeling as much as I possibly can. So let's see, I am reeling in my fish at 2 feet per second. That's really this distance right here that's changing by 2 feet per second. Maybe I'll label this Z, and it's changing. So I will say dz dt. All that means is that Z is changing with respect to time, or it's changing over time, at 2 feet per second. Now the line is getting shorter, so I'm calling that -2. Hopefully that makes sense. And my bridge is 8 feet high. I'm going to label that. Maybe I'll call this X, and I'll call the bottom, how about Y? Yeah, and I'm interested in knowing how fast the fish is moving through the water when it is 10 feet from the bridge. I will label that 10. All right, I think I can probably, let me get rid of that 5. It just looks distracting. It looks like 10 to the 5th there. All right, I think I could probably figure out what Z is right now, right, if I just use a Pythagorean theorem. And that's kind of the tricky thing. It's like I can figure out the dimensions now. I want to figure out how the dimensions are changing. All right, so Z I can just figure out by doing Pythagorean theorem. 8 squared plus 10 squared equals Z squared. So that is 164 is equal to Z squared. So Z is equal to the square root of 164. That's not going to be a nice number there, so I'll just write, it's not a perfect square, so I'll just write square root of 164. That's a 4, not a 9. All right. What other information do I have? Well, let's see. What am I actually looking for? I'm looking for the speed that the fish is moving through the water. That's this right here. I'm actually looking for the change in this dimension, change in y. So that's dy dt, question mark. How high is or how fast is this dimension changing, the height of the bridge? Well, the height of the bridge is not changing. So dx dt is 0, right? The height of the bridge is changing by 0 feet per second. Okay, all right, now I'm going to write an equation that relates all of my sides of this triangle here. I think it's pretty obvious what it's going to be. X squared plus y squared equals z squared, the Pythagorean theorem. We're kind of using it twice, aren't we? All right, so now I'm going to take the derivative to figure out how everything is changing. Derivative of x squared is 2x times the derivative of x with respect to time, right? X is changing with time, plus 2y dy dt. This is just implicit differentiation. That's all I'm doing. dz, 2z, dz dt. Yeah, all right. I think I said that right. Now I'm just going to fill in what I have. All right, 2 times x. X is 8. Dx dt is 0 plus 2 times y, which is 10. I'm looking for dy dt equals 2 times z, which is the square root of 164, times how fast that dimension is changing. All right, well, that's -2. This 0, anything times 0 is just 0, so I'm going to be left with dy dt equals 2 times the square root of 164 times -2. This is just going to be a calculator maneuver right here. Over, I'm going to divide both sides by 2 times 10. Hopefully you can see what I'm doing, right? I just divided both sides by that. Just a little bit of algebra there. 2 times 10. Oh man, I'm getting messy, Haas. What's going on? All right. This is just, hey, I can even cancel out these 2's. So I'm just going to stick this in my calculator, and the answer is -2.6. I'm rounding to the nearest tenth. feet per second. So that is dy dt. That is how fast the fish is moving through the water when it is 10 feet from the bridge. Hopefully that makes sense to you. Thanks so much for watching. Bye-bye.